Hello, I'm going to show you how to size and fit an eyepiece reticule. Now, a reticule can be an effective general measurement pattern, or it can be an application-specific device such as a Wharton and Beckett pattern for asbestos analysis, a PSA pattern for pharmaceutical, grain sizing pattern, many others. It can possibly be a reticule that you designed specifically to suit your application. Now, there are many brands of microscopes and types of microscope, most of which can be fitted with an eyepiece reticule. Now, the eyepiece of a microscope is fitted into a tube, and the tube sizes can vary from microscope to microscope, but predominantly there are two general sizes: the larger 32mm as used on this stereo, or the smaller 23mm used on many compound microscopes. Now, this diameter, this 32 or 23mm diameter, has nothing to do with the reticule diameter. The reticule is a simple disc of glass which is put inside the eyepiece tube. Also, you might find some numbers printed on the outside of the eyepiece. These have nothing to do with the eyepiece reticule diameter either. The numbers refer to magnification of the eyepiece and the field of view. Normally, the reticule is slightly larger than the field of view to allow it to be fitted. Now, finding published information on the correct diameter to fit your specific eyepiece can be difficult. Now, to help with this, we have compiled a list of eyepieces and the corresponding reticule diameters required to fit them. Now, this handy lookup can be found on the PISA website. Called reticule diameters for common microscopes, the reticules are listed in major brand groups. Now, the major brands include Nikon, Olympus, Leica, Zeiss, and many others. In fact, there's over 160 eyepieces listed, and you can see here the link on the page, and I will provide the link in the description of this video.
There are many different designs of eyepieces to suit various microscopes, different eyepieces matching every manufacturer and microscope model. Some modern eyepieces can be very complex, containing 5 or more separate lenses to provide the absolute best view obtainable. We're going to review the eyepiece type fitted to the vast majority of microscopes from most manufacturers. These are the corrected simple eyepieces or Kellner design. The basic Kellner eyepiece has 2 variations, and many of them can be fitted with an eyepiece reticule. The Ransdom type has all its lenses above the reticule mounting position and presents an open tube from the bottom to give access to the mounting location. Some may still require some disassembly to fit the reticule, but in general it's far simpler to measure the tube and fit the reticule to this type of eyepiece. The Hygienian type has a lens element at the top and bottom, with the reticle mounting location somewhere in between. This type always requires the eyepiece to be open to gain access to the mounting shelf, if indeed it has one. Some of these types of eyepiece do not readily accept a reticule, having no mounting shelf within the tube. So let's look at how the task is done.
We're going to fit some reticules into the 2 eyepieces we have here. The most important thing when doing this job is keeping the new reticule and the eyepiece assembly clean and free from dust, dirt, fingerprints. It's very important. There's nothing more distracting than a small piece of contamination obscuring the view, especially when you know you're the one that put it there. The lines on the reticule are 15 microns in thickness. Thin human hair is somewhere between 40 and 60 microns, so that's about 3 times as thick. So you can see that it doesn't take a very large particle of dirt or fibre to spoil the view. From experience, repeatedly removing and cleaning and refitting the reticule to complete a dust-free fitting can be very frustrating. So a few basic tools and preparation is a worthwhile investment. First, ensure that your working area is clean and dry and that you have the necessary bits and pieces and tools around you. It's essential to ensure that you've got some cleaning optical fluid, some lint-free tissues. Optical cleaning kits are readily available which have all of these in it, and they may come along with some additional items and tools such as brushes or anti-static cloths like this one, or speck grabbers, which allow you to take individual specks of dirt or dust from particular glass. But in my opinion, the most important tool in the whole kit is a pair of rubber gloves, these lab gloves. Make sure you don't get any finger marks on the assembly. They keep finger marks at bay. Now, one of the most common causes of contamination comes actually from the eyepiece itself. When you unscrew an eyepiece assembly like this, you can get small fragments of the black coating come free and they fall inside the actual eyepiece. Now, when you reassemble this later falls down onto the eyepiece reticule. This debris is now trapped inside the completed assembly and it can't be removed. Even if it's slightly out of focus, this can be a nuisance. So remember, do clean the eyepiece components once disassembled. A new reticule will come from the factory, clean and in a lint-free wrapping. So if opened carefully and handled with gloved hands, it shouldn't be too much of a problem. Okay, measuring the size of a reticule. Now there are two types here. This one is an Hygienium eyepiece. You can see that there's a lens here and here. So this is the eyepiece lens, the field lens is on this end, and in fact it does unscrew. And the position for the reticule is actually just inside here. There's a shelf just inside this eyepiece here, and that's the position where we're going to fit the reticule. First we need to know what side it's going to be. So if we zero our micrometer and just go inside and check. Okay, this is reading a little over 19.3, 19.4 millimeters. So it's a 19 millimeter standard size, which we've got one here. And this would actually fit inside that eyepiece. But before we put this in, it needs to be cleaned. So the best way to clean it is take some lint-free tissue like this. If you fold the tissue into a square and use the corner as your cleaning area, as your cleaning surface, apply some cleaning fluid. There we go. And then working on the eyepiece from the center to the outside in a rotational circular motion like this. Just moving continually to the outside. You're moving any dirt and dust that you trapped to the outside edge. Now similarly, you do this on the reverse side. Move to the outside edge. Finally, just give that a bit of a clean polish and dry, like this. It's important to make sure it's dried properly, otherwise if the fluid dries wet on the glass you get a sort of watermark or water cleaning fluid mark on there. We don't need that. Now, a reticule has two sides. The orientation of the reticule can be difficult to see while it's out of the eyepiece. Now, if we get this round the wrong way, when you look through the eyepiece, any text or numbers is going to be the wrong way round. Now, the way that it's intended for use is in the following manner. You look through the eyepiece from this side down through the microscope, and similarly through the eyepiece reticule to the side which has the chrome image on. So you're looking through the glass to see the chrome image. So we need to assemble it with the chrome image on the downside. So put that in there. There we go, fits in nicely. Probably can't see that, but I can see a chrome image in there. Now we've got to fix this in place. In this case, I'm using a circlip. Now, this circlip is simply being made by taking a piece of sprung steel wire, winding it and forming it round a rod, and then cutting it afterwards. So we've got a nice simple circlip. Some eyepieces will come with screwing collars and so on, but in many cases you'll find you're not going to be that lucky. So what we need to do now is fit this circlip into the eyepiece. Now breaking our gloves. There we go. And that will hold the reticule in place. me just give that a quick clean as well. Good. Lovely. And we'll reassemble the field lens back into this Hygienian piece, and here we have a working eyepiece. That's how you do a Hygienian. Now, this is a Ramsden one, and you saw me open this one earlier. So in this case, we're looking at an open tube here, and the lenses are in this piece here. You can see the lenses here. So this is the eyepiece lens, and there is the field lens about here, and the reticle is actually held in this open tube. Now it's a little bit like the diagram you saw earlier. As you can see, there is a shelf here which holds the reticle itself, and that is what we need to measure now to get the dimension for the reticle to fit this one. So again, zeroing the micrometer. Let's work inside there, working on the right side. Now this is reading just a fraction over 20.5. It could be a little bit bigger. I think we could possibly get a 20.5, but I think maybe a 20mm would fit in there as well. So I have one here which is actually 20.5 to go into a 20.9 fitting. So again, we need to clean this up in the same way as we did earlier. Nice fresh piece of tissue, of course. Always important to change your tissues when you do this. It's a little bit lazy not to do that. And of course you can transfer anything you've cleaned off back onto your new reticle. So again, working from the centre to the outside in a circular motion on both surfaces. And then ensuring that we got a nice, cleaned, polished. There we go. Now a case of working out which side, this is a horizontal scale, 10mm scale, which side the chrome of the glass of chrome is on can be difficult to work out. A little bit of trial and error can help, but I can see it's actually on this side. So we need to put this looking down through the tube this way round. There we go. So that's fitted in there, seated in there. Again, as you saw on the last one, we're going to use a circlip to hold this one in place. This one's actually a circlip with a pointer, but I probably wouldn't use a pointer one normally, but there we go. So a circlip in here. It's the downside, of course, of using gloves. It can be a bit awkward. It's far harder with marigold. Now then, reassemble. And there we are. That's a nice working reticle, nice and clean. Numbers around the right way. So we've actually fitted those together correctly. They're ready now to go back into your eyepieces of your microscope.